So back with problem 6, the percent of U.S. high school seniors from 1997 to 2006 who used marijuana can be modeled by that equation, where x is the number of years past 1990. Our job is to interpret the slope and the y-intercept of this thing. So we've got p of x is 56.009 minus 0.758x. Okay, and so let's get started with the slope. In this case, the slope is the number attached to the variable, so that is 0.758, negative 0.758, meaning that every year the percent of high school seniors who smoke marijuana drops by 0.758%. Okay, and the y-intercept is 56.009, meaning that in the beginning, or in this case, 1990, 56.009% of high school seniors smoked marijuana. Okay, so that's it for interpreting the slope and the y-intercept. In what year does this model predict that the percent of high school seniors who smoke marijuana will be 0%, and is this realistic? Why or why not? I'm going to say that prediction is probably unrealistic because getting to 0 is probably not going to happen. But what we would do in that case, folks, is we would have P of, no, we're not going to have P of, we want that to be 0. So we're going to have the percent be 0 is equal to 56.009 minus 0.758x. So again, we're going to bring Wolfram in to do the math for us here. And we're going to swing 0 is equal to 56.009 minus 0.758x. And so this model is predicting, let's find our solution, 73.8905. And that would be 73 years after. In the case of this problem, what year were we starting with? 1990. So that would be, the model predicts that 0% of high school seniors will smoke marijuana in the year, let's see, 73, 74 years after 1990 is going to be 2064. Is it realistic? Why or why not? Probably not realistic. Depending on your stance, that could be it would be nice maybe for that to become 0, but probably not something that we are actually going to see in reality. With that, everyone, that's it for 6. We're on our way to 7.